Here we're given a vector of length 6 pointing straight down, and we first want to express it in terms of its xy components, and then we want to re-express it in terms of its x prime, y prime components. Let's start with the xy components. So we have a vector length 6 pointing straight down. Notice that it's purely along the y-axis already, so there's actually nothing to break up. So we can simply write this vector as 0 units in the x-hat direction plus negative 6 units in the y-hat direction. The idea being that this vector has length 6, but it's pointing in the negative y direction, hence the minus sign in the negative 6 here. Now that was pretty straightforward. Now we want to express it in terms of x prime, y prime coordinates. And in order to do this, we're going to need to write this vector as part of a triangle, a right triangle. And let's remember our rules. One leg of that right triangle goes along one of the axes, and the other leg of the right triangle goes along the other coordinate axis. And the vector itself, this red vector here, always forms the hypotenuse of that right triangle. So let's draw that right triangle. One leg of that right triangle will run parallel to the x prime axis. And the other leg will run parallel to the y prime axis. There we have our right triangle. Again, notice the key features are that the original vector is always the hypotenuse of that right triangle, and one leg is parallel to one axis, and the other leg is parallel to the other coordinate axis. Next, we'll use a little geometry and trig to figure out the lengths of each of these legs of the right triangle. Notice that if this is angle 35 degrees here, then this angle right here must also be 35 degrees. As a reminder, if I look at this line and I look at this line, they cross one another, and by the law of alternate interior angles, this angle must equal that angle. Now, notice that if this is a 35-degree angle right here, and then look at this dashed line here and here, you see how they form a 90-degree angle here. Therefore, it must be the case that this angle right here is 90 minus 35, namely 55 degrees. And now we're in good shape. From trigonometry, the length of one leg of the triangle is 6 cosine 55 degrees, and the length of this other leg of the triangle is 6 sine 55 degrees. So now we're ready to express this vector in terms of its x prime, y prime components. We write it as 6 cosine 55 degrees, and that's in the positive x hat prime direction. Again, the way I'm getting that is I'm looking at this arrow. The length of it is 6 cosine 55, and I look at the direction of that arrow, and it's pointing along the x prime axis. So it's pointing in the positive x hat prime direction. Likewise, if I look at the other leg of the triangle, it's of size 6 sine 55 degrees, but if I look at the direction it's pointing opposite to the y prime axis. So it's in the negative y hat prime direction. And there we have it.